Hello everyone and welcome back to the next session on pointers. In this particular video, we are going to have a look at function calls and pointer expressions. What I call it as back to function calls. Now there are two types of function calls. One is call by value and another one is call by reference. If you try to recollect the topic of functions that we have seen earlier, right? Any user-defined function was actually made of three components. The first one was function declaration, which was also called as function prototype. The second one was function call. And the third one was function definition. Even though couple of codes that we have seen in the functions topic basically belong to call by value, the focus over here will be the difference between the two function calls, what is called as call by value and call by reference. So that is what is the discussion of topic as of now, call by value versus call by reference. I have pictorially represented the thin line difference between call by value and call by reference, right? So I have a function where I'm going to pass the parameters, and in the user defined function, let us look at the status of the parameters. What happens, right? If it gets modified, then you are actually implementing call by reference. And if it is not, then you are actually you are actually implementing call by value. So let us look at both of this one by one. The first one is call by value. What happens here? When we pass the actual parameters while calling a function, then this is known as function call by value. In this case, the values of actual parameters are copied to the formal parameters, and thus operations performed on the formal parameters do not reflect in the actual parameters. Okay, so that is what you mean by call by value, where the operations performed on the formal parameters do not reflect in the actual parameters, right? So let us try to understand this call by value with the help of a code. So as usual, I'll go to my online C compiler, and then let me have a code for you. So I'll declare two variables A and B and initialize it, and the values of A and B are 10 and 20. So this is my function call, you know very well. This is my function call. And then what I'm going to do is I'm trying to print the value of variables in main program. And this is what I have, my function definition. So I need to use one temporary variable. Okay, so when you look at this, I have a function called as swap, which I'm calling with two parameters A and B, and hence the function swap is called with 10 and 20 as a parameter. Control comes to line number 9, X gets 10 and Y gets 20. Okay, so I have this temp, and these three lines, I don't think I need to explain you. Line number 11, 12 and 13 will do the job of swapping the contents of two variables. Okay, so let us run this particular program. Yeah, so this is what it is. When I'm calling a function from line number 5, it goes to the function line number 9 where function definition is written, and it will swap, and then it will say in function x equal to 20 and y equal to 10. And once the user defined function, all the statements are executed, correct? The control from line number 15 will come to line number 5, and then it will go to line number 6, and it will print the value of a and b, which is actually available in main program, and the value of a and b in main is 10 and 20, right? So the variables which were passed to the user defined function as 10 and 20 got swapped inside the function, right? But when the control came back to the main program, we still had the original values of a and b, which is 10 and 20, right? So this is what you mean by call by value, right? Where we say that operations performed on the formal parameters do not reflect in the actual parameters. So the in call by value, the values of the variables in the main program will not be affected, right? So that's the meaning of it. That was the code that we had edited in the online compiler, and you have seen the output of it. Okay, so let us move to the next point, that is call by reference. Now call by reference is actually or exactly opposite of call by value. Let us see what it is. When we call a function by passing the address of actual parameters, then this way of calling the function is known as call by reference. Means what? If you recollect the earlier call by value code, we sent a and b as a parameter, right? That is the values. Now in call by reference, we are going to call the function, but we are not going to call the function with values as parameters. On the other hand, we are going to call a function with address as the parameter. I mean, the address of the variables will be sent as a parameter to the function. So that's what we say when we call a function by passing the address of actual parameters. This methodology of calling the function is known as call by reference. Now, what happens in call by reference? In call by reference, the operation performed on the formal parameters affects the value of the actual parameters, because all the operations performed on the value stored in the address of the actual parameters, right? So the thin line difference is in call by reference, the values of the variables in the main program will be altered, will be affected. Now, let us also look at a particular piece of code with respect to call by reference. So I already have call by value code here, so I'm not going to rewrite it. I'll just do the necessary changes which will enable me to justify as to what happens in call by reference. Okay, now watch out this. This was our code, okay, where we were calling a function with values as parameters. A was 10 and B was 20. Now in call by reference, I'm going to call the function with address as the parameter. And you know, address is given by ampersand symbol, and hence I will call a function with ampersand A and ampersand B as a parameter, right? So this line now signifies that I'm calling a function with address as a parameter. And the moment I do that, it becomes call by reference. Okay, so I repeat, the moment I call a function with address as a parameter, it becomes call by reference. Right, now let us see. Of course, there's not going to be any change in the printf function of main. Let us see what are the changes in the function definition. So the first change that is going to happen is, since it is a pointer variable, I have to use star because we are calling address as a parameter. And then I will say so in function, now my x will be star of x and my y will be star of y. Okay, so this is the change that is going to happen. Let us compile and run the program and see. Yeah, here it is. So I get in function x equal to 20 and 10, which you already got in call by value as well. But then when the control goes back to the main program, you are getting the value of the variable changed in the main program. In main, where the value of a was 10 and 20, now after call by reference, it became 20 and 10. Okay, so this is the fundamental difference between call by value and call by reference, where in call by value, values of the variables in the main program will not be affected, but in call by reference, the values of the variables in the main program will be affected. So this is the code of call by reference. I'll just give you a couple of seconds. Please have a look at it and try to understand. So for the benefit of all of you, once again, let me tell you what happens in call by reference. Here, you notice that when function swap is called, address, that is, we also call it as a reference, that is why it is called as call by reference, address of variable a and b is passed. These addresses are collected by pointer variables. Understand, these addresses are collected by pointer variables, right? Let me show you in the code itself. Okay, so this is what it is. Line number 5, I say that function swap is called with address of a variable, right? So address of variable a and b is passed. Now what happens in line number 9? These addresses are collected by pointer variables x and y, right? So you see it is collected by pointer variables x and y. That is why I have denoted as star x and star y. Okay, through these pointer variables a and b can be indirectly accessed, right? It can be indirectly accessed and hence values gets exchanged, right? The values gets exchanged, and that is what we have seen in the program, right? So that is how call by reference actually works in C language. Now let us move further and see what is called as pointer expressions. Like any other variables, pointer variables can be used in expressions. Now let us look at few aspects of pointer expressions. The first one is called as pointer assignment. Now what happens in pointer assignments? We can assign one pointer to another pointer which is similar of assigning value of one variable to another variable. Okay, so what does pointer assignment mean is we can assign one pointer to another pointer which is as similar as assigning the value of one variable to another variable. Okay, so we can go for the assignment provided both pointers are of same data type. Now that is extremely important, right? We can do such type of assignment provided my both pointers are of same data type. Okay, so let us have a look at it. I have this piece of code and let me see how pointer assignments can be made in C programming. So let me code it for you. So I'll have same variables int a is equal to 10, b equal to 20, and I'll have two pointer variables. I will say int star p1 comma star p2. Okay, and then I will say p1 is equal to ampersand of a and p2 is equal to ampersand of b. So I don't need this line. I'll slightly change the printf. Values at p1 will be equal to, or I can say p1 is a little bit better English. P1 is percentage d and p2 is also percentage d, but here I need to say star p1 comma star p2, and of course I don't need this anymore. Okay, so this is what I have with me, right? So let us see what happens with this. Yeah, So it gives the output as values at P1 is 10 and P2 is 20, right? So you look at it, P1 is equal to ampersand of A, correct? So whatever the A is stored, right, the address where A is stored will be assigned to P1, and star P1 will pick up the value at that particular address, right? So this is what we call it as pointer assignment, right? So how this line number 6 is interpreted, it is nothing but, right, see, this star P1 is nothing but star of ampersand of P1, or correct, star of ampersand of A. And you know very well, right, star of ampersand of any variable is actually variable itself, right? And hence what happens, the value of star P1 is 10 and value of star P2 is actually 20. So this is how pointer assignment takes place in C programming. So that is the diagrammatical representation of the pointer assignment, right? So I have the variable A stored as 10, which is stored in address 100, and P1. Okay, so that's a small change. Actually, this should be 100 and this should be 200, right? So variable A is stored in address 100 and P1 is ampersand of A. So P1 gets 100, and similarly, because of the statement P2 is equal to ampersand of B, P2 gets as 200. So this is the diagrammatical representation of that particular code that we have developed, which says how pointer assignments can be made in C. Now, if I have like this, P1 equal to P2 and P2 is assigned to P1, that means both P1 and P2 refer to the same variable. Look at this, right? Both P1 and P2 refer to the same variable, right? So if I have a code like this, right? So this is a diagrammatical representation. Let us try to modify the code a little bit. So I have this, I'm not going to change any one of these, right? But instead of that, what I'll say, P2 is equal to ampersand B, I'm going to have a simple assignment statement which says P1 is equal to P2, right? And then I'm not going to change anything, right? So let us see what is the implication of this particular statement, P1 equal to P2, on this particular code. Yeah, so that's what I see, right? So values at P1 is 20 and P2 is also 20. In the earlier case, P1 was 10 and P2 was 20, right? But here, what we have done is, we have said P1 is equal to P2. And this particular statement makes the value of P1 also to print as 20, right? So this is what it says, that both P1 and P2 refers to the same variable. So have a look at the diagrammatical representation of it. Okay, let's move to the next point, that is called as pointer arithmetic. Now listen carefully what happens in pointer arithmetic. A pointer in C is an address which is a numerical value. You know this very well. Therefore, you can perform arithmetic operations on a pointer just as you perform on a numerical value. That means what? The pointers can be incremented, decremented, and a value can be added or subtracted in order to modify the contents of the pointer variables. Okay? But remember, pointer cannot be multiplied or divided by any other pointer or a number. So you have to keep this in mind as a C programmer, that in case of pointers, only addition and subtraction is permitted. On the other hand, multiplication and division is not possible in case of pointers. Let me also tell you that most common operation on pointers is actually incrementing a pointer. Majority of the applications you will come across where the programmer has implemented the concept of incrementing the pointer. Now this is what it is, right? P is pointing to memory location 2000. Now there is a memory map in front of you where I am making use of variable p, which is stored at address 2000, and the value of p is 10. Okay, so ampersand of p is nothing but 2000. Now what happens when I say p plus plus? It will point to the next integer, right? Integer means it is a integer pointer, and hence what happens, if p is a pointer, p will contain 2002 and not 2001. Please understand, right? If p is an ordinary variable, then it will increment by 1, but here p is actually a pointer variable, and hence when you say p plus plus, it will contain 2002, right? Because assuming that integer occupies 2 bytes, 2000 plus 2, right? It is actually incrementing by one location. P plus plus means incrementing by one location. So 2000 plus 2 becomes 2002, right? So each time a pointer is incremented, it points to the memory location of the next element of its base type. Understand? Next element of the base type. So 2000 will point to 2002. On the other hand, each time when it is decremented, it points to the location of the previous element. So when I say 2002, if it is 2000, if it is decremented, it will point to the previous integer location with related to its base type. That will be 1998. Now, in a nutshell, let me tell you what is this slide all about. When we increment a pointer, its value is increased by the length of the data type that it points to. Okay, I repeat, when we increment a pointer, its value is increased by the length of the data type that it points to. This length is called as scale factor. Very important point. This length is called as scale factor. Okay, so that is what I said. Make a note of this. C compiler takes the size of the data type being pointed to into account while performing the arithmetic operations. Okay, so let us try to understand this with the help of an example, the pointer incrementation. So I'll go back to my online compiler and let me have, I don't think I need two variables. I say int a equal to 10, and here also I can get rid of it. And then what I can do is I can assign the address of a to p, and now here is where p plus plus I am trying to do pointer incrementation, and then I will say now p is percentage u. I'm trying to print the address of p. Okay, so line number 8, p plus plus, is what I am trying to do pointer incrementation. Okay, so let us run this code and see what is the output. It says compilation failed due to this. Okay, then it's a warning. P is percentage u. I think actually it should work. Yeah, so here is what I have the output, right? So my line number 7, right, it gives the output as this one. Okay, so don't worry about such a big number, just focus on maybe the last 4 digits, right? Because the first 6 digits, I think it is same, 187973, and here also it is 187973, so don't worry about it. Now let us focus on the last 4 digits. This is 2836, right? So let us consider the last 4 digits as the address, okay, for our understanding. So I can say the variable a is stored at 2836, and that is what line number 7 is printed. Now p plus plus is a pointer incrementation by 1, right? So when line number 7 printed 2836 p plus plus, please understand it will not add 1 to 2836 and make it 2837, and then you'll end up telling in line number 9 the answer is 2837. No, because p is not an ordinary variable. If it was an ordinary variable, then I do agree what you said is true, that 2836 plus 1 is 2837. Since it is a pointer variable, right, we have already made a statement that it, whenever the pointer incrementation takes place, it will always point to the next element of its base type. Now what is the base type? Here it is a integer, right? And assuming that integer takes 2 bytes or 4 bytes, now in this case it is taking 4 bytes, and hence what happens, it will be an addition of 4 to this 2836. That means 2836 plus 4, right? P plus plus is actually incrementing by, meaning it is incrementing by 4, and hence 2836 plus 4 is 2840. Okay, so this is how the pointer incrementation takes place in C. Okay, similarly, let me go for pointer decrementation. I just have to do a small change and I just say P minus minus. Okay, and then you see the change here, how it reflects. So let us again, don't bother about first few digits. Let us take the last 4 digits, right? So P is actually stored at 9812, and then P minus minus, you are actually decrementing. Decrementing is again not by 1 as a value, but 1 with respect to the pointer. And hence what happens, it will be 9812 minus 4, so it will be 9808. Okay, so this is how basically the pointer incrementation and pointer decrementation takes place in C. So let us look at pointer comparison. The question that comes in my mind is, can we compare pointers? You know, when we studied relational operators, we always used to compare two operands using relational operators. Now the question that comes to my mind is, right, can we compare pointers? Right? Yes, the two pointers can always be compared. Understand, right? So what does the 3 points that I have given tells you? That we have already seen pointers in different expressions and arithmetic operations, right? And the two pointers can also be compared is the statement that I made a couple of seconds back. Pointers can be used in conditional statements as other variables. As usually we have used the variables, we can also use pointers in conditional statements. All the comparison operators can be used with pointers, right? That means what? All relational operators can be used with pointers, whether it is less than, greater than, or not equal to, all the 6 relational operators, right? For example, suppose in sorting an array, we are using the 2 pointers. Now to test which pointer is at higher address, we can compare them and take the decision depending upon the result. Okay, so the bottom line is, pointer comparison is valid only if the 2 pointers are pointing to the same array, right? That is extremely important. And as I told earlier, all relational operators can be used for comparing the pointers of the same type. And the last one is, all equality and inequality operators can also be used with all the pointer type. Okay, now let us try to understand this with a particular piece of code. So I go back to my normal compiler, and probably I require 2 variables to show you the demonstration of this code. And I'll go to my 2 pointer variables as well as P1 and P2. So these things you are already aware. Now what I'll say is P1 is equal to percentage %u, and P2, let me print the address of it. P1, P2. So now I'll use my decision control structures and I say if P1 greater than P2, I just make a statement P1 is greater than P2. Otherwise, I just make a statement P2 is greater than P1. So I have this code with me, right? So let us see how the pointer comparison takes place. Actually, percentage U should work. So I have two variables star P1 comma star P2. This is fine. P1 is equal to ampersand A, P2 is equal to ampersand B is also fine. If P1 greater than P2, syntactically this also looks to be fine. Okay, yeah, here it is, right? So that's fine. Committing syntax error is always C programmer's birthright. So this is what you look at it. See, so let us again look the last four digit, because from the discussion point of view, so this is 1784 and this is 1788. So I say that P1 is sorry, P2 is greater than P1 because the address where P2 is stored is greater than the address where P1 is stored. So that is what I mean to say, that you can always use the relational operators along with decision control structures to land up comparing pointers of two types, right? So this is the code. Just have a look at it.